Hello, this is Magnus speaking. In this video I will explain the development process of a control system software for a waterborne floor heating system. The system consists of a pump that circulates hot water through the floors and back to a boiler to heat it again. A mixing valve uses the cold water from the return pipe and the hot water from the boiler to adjust the temperature of the water going out through the floors. A series of other valves adjust the flow of this mixed water into the individual rooms, giving regulation of temperature in each room. As of now, the mixing valve is manual, and the pump turns off only when the return pipe is warm enough to exceed the set point of the bimetal-based switch. A digital controller will provide better control and make it easier to add control features later on. The software was developed using the unified process, and the first step of designing an application is the elaboration phase. Here the requirements are established and the framework for the application is built. This system will consist of the user interface, the data layer and the logical layer, or the controller. The main part being the logical layer, as it will run 24/7 to maintain the desired temperatures. When these three parts are implemented and are communicating, the next phase can begin. The construction phase. This system was found to have 5 use cases. It has to control the pump, control the outflow temperature, and control each individual valve that opens and closes the loop going out to each individual room. The more underlying use cases are the handling of data and error messages. The first and most important use case was selected to be the control of the mixer valve, as it controls the source of heat to the floors. With an even temperature coming from the outflow, the overall evenness of the system would hopefully improve. To obtain control of this temperature, the system would first have to check the pump to see if it's running, as it is necessary to control the temperature without flow. Next, it needs to grab the configuration for the controller, including the desired set point. The temperature can then be collected before the controller can do its thing. The values are checked before they are given to the controller to avoid temperature readings that are outside the possible range. It should never get lower than 15 degrees and never higher than the temperature of the boiler, which is 60 degrees. For the controller, I opted for a PID controller because it is easy to implement and to tune. After the PID controller is finished calculating, the new position is sent to the valve. Finally, the valve position and temperature reading are stored in the database. These steps will loop continuously with a fixed sampling rate, initially set to 5 seconds. But the user will be able to change this if they want to. When testing the application after implementation, a simple simulator was made instead of connecting to a physical device. This is because the .NET Core framework does not support serial communication, which was planned to be used as the interface between the server and the analog sensor. After giving the simulator similar behavior as the system, the simulation you see here was run, and the results were saved to a CSV file instead of the database, as the database is not yet constructed. As you can see from this graph, the controller works well under ideal circumstances, and because it is tunable, it should also work fine with the real components. Because of the issue with the serial communication, a new development platform or communication protocol will have to be selected before going forward and implementing the software. Going forward after that, the next step is to select another use case to construct. Controlling the pump will most likely be the next step in the construction phase, as these 2 use cases combined will give the software full control of the heat source. After that, the user interface must be made before the loops can be controlled, as the set point for each room must be set before the controller will know what to do. With the user interface developed, the error handler can also be implemented, along with the database. That's it for now. I hope I'll be able to work on this project until it's completed. Thanks for watching and stay safe.